Hi guys, welcome to our video lesson in which we're going to finish section 5.4. In class today, we solved radical equations, and in this video, we're going to solve equations with rational exponents. As we learned at the beginning of the chapter, rational exponents and radical expressions are related with the following rule. If I have the rational expression a to the exponent, that's m over n, I can write that in radical form as the nth root of a to the m, or the nth root of a taken to the m power. We're going to need to use that today when we are using rational exponents to solve equations. So when we are presented with an equation with a rational exponent, we know that it can be written as a radical. So because of that, we solve it very similar to how we did with our radical equations. However, to undo a rational exponent, we take both sides to the reciprocal power. So again, we're taking both sides of an equation to an exponent, but when we have these that already start with rational exponents, we just take them to the reciprocal power that is there. So let's look at letter A. We have the quantity x plus 30 to the 1/2 power equals x. So the first thing we need to make sure is everything that's taken to the exponent is by itself on one side of the equal sign. And that is good with this one. So we're ready to go. Now, once that part is done, we take both sides of the equation to the reciprocal power that is there. So 1/2, the reciprocal is just 2. So when that happens, I'm left with x plus 30 equals x squared. So I have a quadratic, which means we're going to want to set this equation equal to 0, and hopefully we can factor that. So let's subtract x and 30. And we have 0 equals x squared minus x minus 30. And we ask ourselves, what multiplies to negative 30 and adds to negative 1? That would be a negative 6 and a positive 5. So this factors to x minus 6 times x plus 5 to give us the potential solutions of positive 6 and negative 5. Just like with radical equations, we do need to check the answers because there could be extraneous solutions. So let's first check x equals 6. So remember, we have to put this in the original equation before we did anything to it. So we are going to take 6 plus 30, and that's raised to the 1/2 power. Does that equal 6? Well, 6 plus 30 is 36 to the 1/2. And yes, that does equal 6 because remember the 1/2 power is the same thing as the positive square root of 36, which is 6. So x equals 6 is definitely a solution. So let's check x equals negative 5. So negative 5 plus 30 to the 1/2, does that equal negative 5? Well, this would be a positive 25 to the 1/2 power. Does that equal negative 5? And the answer to that is no, because 25 to the 1/2 power would actually give us positive 5, not negative 5. So x equals negative 5 is an extraneous solution, so we just have one solution, x equals 6. Okay, moving on to letter B. Our first step is to get the rational exponent expression by itself. So I need to get rid of this plus 2 by subtracting 2 on each side. So now I have the quantity 2x to the 3/4 power equals 10 minus 2, 8. Okay, now my next step is to take each side to the reciprocal power that is done. So this 3/4, I'm going to take this to the 4/3 power. Same thing with the 8. And you may be wondering, why take it to the reciprocal power? Well, when we take a power to a power, as we have here on the left side, remember that you multiply exponents, and 3/4 times 4/3 is 1. So it essentially cancels that out. So now we're just left with 2x equals 8 to the 4/3. And at this point is where we have to remember what I wrote up top. This rule up here, and this is the one that's going to be our friend. So we are going to change this that has a rational exponent, and we're going to put it in radical form. So we still have 2x on the left, but I'm going to write this as the cubed root of 8, and then that's to the 4th power. So I just keep simplifying. The cube root of 8 is 2, okay? And 2 to the 4th is 16. And now I can divide by 2, and I get x equals 8. Now we want to make sure that this is a true statement. So if I plug 8 in to check, that's going to be 2 times 8 to the 3/4 plus 2. Does that equal 10? All right, 2 times 8 is 16. Now that's 16 to the 3/4. So that would be the 4th root of 16 cubed. Okay, the 4th root of 16 is 2, so that's 2 cubed. And we know 2 cubed is 8, and 8 plus 2 is 10. So sure enough, that is a solution. All right, 2 more, and we're going to do the last 2 in class. So letter C, I have 3x to the 1/3 power equals -3. This is kind of a simple one because our expression with a rational exponent is already by itself, and the power is just 1/3, whose reciprocal is 3. So we're just going to cube both sides. So that leaves us with, 3x equals -27. And then you just have to divide by 3. So x equals -9. Now plugging that in the original, 3 times -9 to the 1/3, does that give me -3? So 3 times -9 is -27 to the 1/3. Does that give me -3? Yes, it does, because remember, you can take the cube root of a negative number, and that will give you a negative number. So this is true. I actually want to change the problem in letter D, so please cross out. We're going to change this problem. We are going to change it to 3x to the 2/3 minus 30 equals 18. Okay, so let's get going. We need to isolate whatever is taken to the rational exponent. So we need to isolate x to the 2/3. So what I need to do is add 30. And so now I have 3x to the 2/3 equals 18 plus 30, 48. Then I'm going to divide by 3. And I have x to the 2/3 equals 16. At this point is when we're going to take both sides to the reciprocal power. And this one is different than the other ones we've done, and that is because our denominator is an even number. So essentially what we are doing, once I write this with a radical, we are taking the square root of 16, and then we are cubing it. So we are taking an even root, which means we must account for positive and negative, because we ourselves are doing that to solve this problem. So what we are going to get here, the square root of 16 could be plus or minus 4. And then when I cube each of those, I end up getting plus or minus 64. And to save time, I've already put this in my calculator to see if it's true, and I'm going to show that for you. As we can see, regardless if it's -64 or positive 64, we get 18 out. So that for sure is plus or minus. Okay, guys, we're going to finish the last 2 in class.